Welcome back to the channel, guys. Hope you're doing extremely well. This is your very own mascot this side, and today we are going to continue our further explanation of the linked list. Right? We were dealing with the linked list, a beautiful topic, right? So in the previous video, we discussed about the insertion and implementation and whatnot about the doubly linked list, right? But in this video, let us come back to the singly linked list once again, right? Singly linked list. Right. So the question we have in our hand is reverse a linked list. Reverse a linked list. That is, the linked list will be given to you such as the given input, that is 1, next pointer is 2, whose next pointer is 3, whose next pointer is 4, whose next pointer is 5, and whose next pointer it is not mentioned here but will be null, right? And the questions demand you that it will provide you with this head only, and you will have to return him a new linked list which will look something like 5, 4, 3, 2, 1, and now 1 should be connected to null, right? 1 should be connected to null, and 5 is my new head here. So question expects me to return this head only, not the whole linked list, because if I have the head I will actually get the whole linked list. So I want to return only this head, and I am getting only this head. So the question is fairly simple and fairly understandable, right? Now let us have a look how can we solve it. So if I try to depict it, what is actually happening. So I have a node with value 1, and its next pointer is pointing to another node with value 2, whose next pointer is actually pointing towards 3, whose next pointer is actually pointing towards 4, with next pointer actually pointing towards 5, and its next pointer is actually pointing towards nothing, that is null, right? Now I want to reverse it. How do I want to reverse it? I want to form new connections such that this node, this arrow, instead of this, it should come something like this. You can see 5 is connected to 4. That is 5's next is actually equals to 4. Now this arrow should not be here. This arrow should be here. Am I right? This arrow should be here. Now 4 connected to 3, right? Now 3 connected to 2. That is 3's next should be connected to here, right? 2 connected to 1, that is 2's next should be connected here, and 1 equals 1 connected to null, that is 1's next should actually be lying something here, that is null, right? Okay. So what is the approach that I can use, right? So approach 1, which is usually the brute force approach. Till now you should have understood that we are always looking at the brute force approach first, then we go towards the efficient if there is any, and then we move towards the end of it, like the optimize approach. So brute force approach is actually very simple. What does I say? I say that I have got a linked list 1, 2, 3, 4, 5, and null, right? I say I take help of an array. I take help of an array. Now what you will say, what do I do with array? Let us say I took an array, as I'm working in C++, so vector int, right? I push all the values of this in the array. We already know how to traverse it. We have discussed it, right? So if I try to traverse it and insert the elements, my array would look something like 1, 2, 3, 4, 5, right? Okay. I say instead of reversing the linked list, reverse this array. The array after reversing will become something like 5, 4, 3, 2, 1. Now you have the order which you want to do, right? You have to order which you want to convert into linked list. So what do? You can actually keep your temp here, because we always traverse using a temporary node, and we actually do not ever change the head node until and unless it is required. My head is here, and what do? I keep my I pointer here. I say temps data changes to this pointer because it becomes 5. After that I move my temp forward, temps data change, and I move my I forward, sorry not to mention it. So temps data changes to 4. All right, I say temp move forward, I move forward. Temps data changes to 3, it is already 3. After that I move forward, temp move forward. Temps data is changing to 2. I change it to 2, move my temp forward, move my I forward. I see temps data changes to 1. Temp move forward, I move forward. You can see both of them move out of bounds at the same moment because they are actually of the same length. And I say I can now return the same head because I've just changed the data. What do? I've just changed the data, right? Now this is actually just for accomplishing the problem, just for submitting the problem, but please, please, please do not try this. The interviewer is not going to like this. First of all, interviewer might not ask such an easy question, but if he asks, do not try this. And if you will follow the linked list till the last, and you will definitely not do this in front of the interviewer. Okay, but still, what is time complexity of this approach? So I used first traversal, that is O of n, to store the elements into the array, right? Second operation O of n to reverse the array, and third operation O of n to actually pull all the elements, that is change the elements of the linked list, right? So it is O of 3n, which is evidently O of n. But what about the space complexity? You are actually using an extra space, guys. You are actually using an extra space of array, which is actually equal to length. So O of n is the extra space, right? I want to remove it. I want to remove it. Is it possible in some way? Is it possible in some way? Yes, you can use the optimized version of it now. So what is the optimized version? Optimized, right? Let me bring down the figure here. So this is what I want, right? The pink arrows actually denote the real configuration, and I want the green configuration to happen, right? Okay, so let me do one thing. I just want to write, suppose I'm standing at 2 right now. My temp is at 2. Why temp? Because we use it for traversal, right? I will keep it repeating it so you can understand and you can actually grasp the linked list, right? So linked list, as I always said, linked list is nothing but array with a pointer. Array with a pointer, right? Don't think linked list is hard enough. Linked list is the easiest topic of data structures, right? Linked list is just an array with a pointer, okay? All you can do in array is you can actually use the index, but in linked list you will have to traverse. Only that is the difference with the linked list, right? We discussed in the implementation part also. Okay, so this is my temp, suppose, right? My temps next, that is currently equals to 3. I am saying about currently, right? And what do I want? And what do I want? I want temps next to be pointing just in the previous, that is just before, right, just before. I just wanted to do something like this. So if I want to point this area to this node, don't I want a pointer here also? Don't I want a pointer here also? You will say head is always lying there. Use the head. Okay, you're correct here. You're correct. But if my temp is here, now the condition is also same. I want my, in the case temps next is 5 now, but I just want my temps next to just before. There is no pointer here. There is no head here. What do I do? So if I don't have something, I make it on my own. That is the beauty of the coding. I say I will make a variable. I have temp already. I make a variable prev, which will just store the just before, right? So I will keep my previous here. And what do I do? Now I keep my previous here and I will say I'm changing the location of temp next to previous. I will change the location of temp next to previous. That is, if this is my temp, I am breaking this connection. That is, this connection doesn't exist, right? As you can see, it has been removed, and I am actually forming this connection. You can see, right? So this connection has been formed. This connection has been formed. I just have to do same things for everyone. Now, there is a problem in this. What is the problem? See, if I changed this location and here, right? For the next node, that is for this node, how will I make temp reach this node? How will I make temp reach this node? The cooperation is how will I traverse, to put in more concise way, how will I traverse forward? So it says call another pointer, call another pointer, call another pointer. I'll say that if before breaking this connection I make a pointer stay here. Let us name it as next, right? I make a pointer same here, right? And I break this connection now. I form this connection. And now what I will do, I will say my previous will become temp. My previous will become temp. And my temp will become my next. My temp will become my next. That is, I just moved both of these location one step forward, and I can do the same step for this node. I can do the same step for this node. Okay, so let me draw it out in a clear way. So what is going to happen, right? So I have 1, 2, 3, 4, 5, null, right? My approach is I will keep my previous as null currently, my temp as my head, right? My head is here right now, right? And now what I will do is I will say while I will use a location. So I will tell you what will come here, right? I will say temps next. Before temps next, I will say next is equals to temps next. All right, that is next comes here. No problem. I'll say now break the connection. That is temps next equals to previous. That is break the connection and form it here. Okay, breaking the connection, forming the connection at the same step, right? So this connection has been made, and our next step should only be equals to move these 3 pointers forward, a step forward. That is previous becomes temp, that is previous leaves this location, comes here, right? Temp now becomes next for the next iteration, that is temps leave this position and comes here, right? Now this iteration is over, right? So what will happen is my previous was here, my previous comes here, my temp was here, my temp comes here. The next iteration starts, next equals to temp next, that is next will go from here and come here. Okay, again temps next becomes previous, that is this connection breaks off, this points here, and previous equals to temp, temp equals to next, that is previous comes here and temp comes here, right? Okay, now moving on, next becomes temps next again, next comes here, right? Temp next becomes previous, that is I break this connection off, I make this connection, and again previous and temps move one step forward, that is previous comes here and temp come here. Again same, next comes, next equals to temps next. All right, no problem. Now temps next, break this connection, form this connection, move the previous, move the temp, right? I'm able to understand that you're not confusing with these cuttings, right? Okay, temp and next, no problem in that. Okay, now in the next iteration my next becomes this, my next becomes this, and I say temps next, that is I break this connection and I do this and I do this. All right, you can see after that my temp come here, my previous come here, my next is also here. Now you can see actually my linked list has been reversed. If you see it clearly, 5 is actually linked to 4, 4 is actually linked to 3, 3 linked to 2, 2 linked to 1, 1 linked to null. That is I have actually, I see that I have got my answer, that is 5 connected to 4, connected to 3, connected to 2, connected to 1, connected to null. I have changed my linked list up to that, right? Okay. Where are my pointers right now? So my pointer temp is actually here, and I don't have any reference to it because this is not a connection. There is no connection between these nodes. Temp is actually null. My next is also null. My next is also null. But my previous is at my 5. My previous is at my 5. So what is my new head? If you can see this linked list and I say that the previous is at 5, you can see that my new head, I'm saying my new head is actually previous. So to return the head of the linked list, I will just say return previous. And what what was the condition of breaking out of the loop? The condition for breaking out of the loop, if you see, temp equals to null. When temp becomes null, I will break out of the loop. That is, while temp is not null, I will continue doing it, otherwise I will break out of the loop. So simple. While temp is not null, I will do the iterations, and otherwise I will break out of the loop. So I hope that is clear to you, and it's time for you to move on to the coding area and do some actual implementation of the linked list, right? So before starting with the code, I would like to request you to follow me in my social media handles, and please, if you're new here, do not forget to subscribe to my channel and hit the like button as much as possible, and I will keep bringing the content for you. Also, a positive comment will actually reinforce my learning, okay? Reinforce my learning and content creation also, right? So leaving all things aside, what do? I say list node star previous, which is initially null, and I will make a list node star temp equals to head. Right now, I would like to bring to your attention that it is a very great practice to make some base cases. What is my base case? I say that if my head is equals to null, that is the length of the linked list is 0, that is there is no linked list. Or there might be a case that head of the heads next is equals to null, that is the length of the linked list is 1. Now visualize, if there is no array or there is array with one element, isn't it already reversed? Isn't it already reversed? So without changing anything, I will just say return your head. Right? This is the thing I will do for the base cases. Now moving on forward and doing some actual coding, my loop was running for while temp is not equals to null. While temp is not equals to null. Right? Now, what was the operation I was doing? I was saying that I'm making another node, list node star next, which will be equals to temps next. My next operation said that temps next will actually become equals to previous, and my after this whole changing of the next pointer is done, my previous will become temp, and before and moving forward my temp will become my next. And when the iterations were done, you could remember that previous was my new head, so I will just return my previous. I hope the code will run fine. Okay, so let us try to run it. Oh, there has been some error. Oh, I put a triple equals to by mistake. Simple typing error. Let us try to run it now. Hope it will work. It is running fine for the sample test cases. Let's try it for the backend test cases as well. And it has been accepted. Thank you for watching the video. Hope you liked it, and please stay tuned for all the linked list playlists. Right? Please watch it till the end, and you will master the linked list. That is my guarantee to you. Thank you for watching. Have a nice day.